Okay, so let's go ahead and apply the survey from men and women and what they would choose, either money, health, or love, and do a full hypothesis test. So just following the same steps as we always have been doing, let's start with step one. So step one is going to be the null and alternative. So in this case, what are we looking for? Are we looking for that money, health, and love are independent, or men and women are independent, or are we looking at the categories? Like gender is independent from the response of money, health, or love, right? So we're looking for the categories. So this category, row category, is gender. And the column category are these choices, right? So whatever they responded with, we'll call it a response. So our null hypothesis is assuming the row and column variable are independent, right? So that means the null hypothesis in terms of our scenario would be that the gender and response are independent. And the alternative would be that gender and response are dependent. Okay, you're like, oh, okay, that's fair enough. Step two is the alpha, so the alpha is 0.05. Step three is determining the expected counts. So the expected is done, and again, we usually do this in the calculator. Just so you know, you will never calculate it by hand, and you're not expected to. You're expected to run the calculator and grab it by what the calculator calculates. So we'll demonstrate that in a second. Part B, we have those two, right? So one is that all or expected counts are greater than or equal to 1, and we can see they're much bigger than 1, so that's done. 2 is that no more than 20% of expected counts is less than 5, and we can see that none of these expected counts are less than 5. Okay, and so now we can go ahead and conduct the p-value. So what we'll do is we'll go to the calculator and we're going to enter everything in, let me put this, enter observed in matrix, and then calculator. So you only need to only enter observed. So that's the only one you have to enter. So if we go to the calculator and go to the home screen. Okay, so we can go to matrix by highlighting the matrix menu. So how we do that is if it is the second x inverse. So hit second x inverse. So notice we have a whole bunch, right? We can put in as many as we want. We only need one matrix because the calculator calculates the expected. And so we'll go to edit because that's what we want to do, is edit one of them. So let's go to edit one. And notice it starts by 1 and then 0, right? Because it's one row, one column, meaning one cell. But we don't. If we come over here, we can see that we have 2 rows. See, now it jumped to 2. And we have 3 columns. And notice now it becomes 6 cells, and we actually have 6 cells, right? Let's match it up. So men and money is this first one. Second column, first row, that's 446. Last one with love, 355. Then it jumps down to the second row, first column, so 46. Second row, second column, 574. And second row, third column, 273. And so there you have it. It looks identical to the observed table. Now the second part is to just quit. Now we stored it. Okay. Now let's go ahead and go to stat, test, and go all the way up to chi-squared. Now, I know what some of you are thinking. You're like, well, we have the expected. Shouldn't we enter that? Yes, I demonstrated the expected counts in the previous example, so you could know how it's calculated. But the advantage we have is our calculator, and that the calculator will calculate it for us. So, in fact, we get to verify that the calculator does it correctly. So let's select C, hit enter. Your observed counts is matrix A. The expected, go ahead and select B, but essentially your expected should just be an empty matrix. That's all. So if you have stuff in all your matrices except letter F, then put letter F. You just need an empty matrix. So all of my matrices were empty. So I put my observed in A, so I'll just put expected to be B. And then I'll color it, and then I'll go ahead and calculate it so you can see what it calculates. And notice that here they give you the p-value, right? But they also give you the chi-square test statistic, and the only additional thing it gives you is the degrees of freedom. Otherwise, you could just go back to the calculator and hit stat and test, and then go up to chi-square and then hit draw. And it'll draw that skewed right curve, and you probably won't even see it shaded. And then notice it, because the p-value is so little, it doesn't even give you a number, it just gives you 0. So it still gives you the chi-square test statistic, but since the p-value is so little, it doesn't even shade the curve on the graph. That's why sometimes it's good to use the chi-squared calculate, because it'll actually give you some digits of the p-value rather than just, hey, it's nothing, you know. It just doesn't have enough room right here on the graph to put all these digits. Okay, so then let's look and see, here are the expected counts. Like, how does it know that those are them? Does it really calculate? Should I really believe Darlene? The answer is, for most things, no, but for this, yes, right? So second x inverse will give you that matrix. And you're like, what? I had nothing in B. I didn't touch it, but somehow there's a 2 by 3. It calculates the expected for you. In fact, let's go ahead and go to edit and look at it. And look at the values in each cell. So here, the expected count for men and money is 63.64, 63.6. For women, 64.36, 64.4. So it knows what it's doing. Your calculator is a machine. So it's going to calculate it for you. So it's a really nice feature. If you want to, you can clear the matrix and just keep using A and B. Sometimes you're just in a rush, you're taking a quiz, so you just use C and D. But remember that one matrices must be observed values, and what matrix you enter in the calculator should be an empty one. So right now I wouldn't use B, I would probably use C, D, E, F, right? One of these empty ones for expected. Okay, so the matrix that you put expected just has to be empty, that's all. Okay, so let's go ahead and finish up the problem. Let's move up. And then so the p-value is equal to, and I'm going to go ahead and write this out so you can see how small it is, 0.0000001,009, right? And the alpha was 0.05. So it is much smaller, right? Super, super small. Smaller than the alpha. So that means that this alpha that was 5%, right? So the here's like p-value, right? Super small. And the alpha area, 5%. So that means the probability of taking another sample and getting the same results is highly unlikely, and therefore that we need to reject the null. And if we reject the null, what does this mean regarding to our claim? Careful. We are very used to our alternative to being the claim, right? But read the last sentence of the problem once again. It says, test the claim that, so claim that gender and response are independent. Gender and response are independent. Our claim was our null. So let's make a note right here. The claim is the null. But the p-value was so small, we rejected the null. So if we reject the null, what else are we rejecting? We're rejecting the claim. And therefore, there is not enough evidence to support the claim. So let's write this out. So we could say that there is not enough evidence to support the claim that gender and response are independent.